All right, yeah, good evening, sir. My name is Sally Joshua, and I'm here with my partner, Kamali Bob. Yeah, so our project name is Arousal Regulator. We are creating an arousal regulator, and the problem statement is this is a graph that describes a problem statement, which has on the x-axis there is the arousal level, and on the y-axis there is the performance scale. So arousal affects performance in a way that when arousal is low, performance isn't that good, and when it's also extremely high, it's also not good performance. But for us to get the best performance from an individual, the arousal level has to be balanced. And on the lowest, when arousal is low, we have signs like sleep, boredom, mild alertness, and when it's high, we have symptoms like stress, anxiety, and panic. So our project is mainly to make sure that individuals, when performing cognitive tasks, are performing at this optimal level such that they can produce the best performance that they are capable of producing. So that is the problem we are solving. And our objectives, we are using real-time feedback. We are providing real-time feedback to individuals about their arousal levels, or it might be supervisors or any other potential customers. And we are providing a platform to analyze EEG data and study arousal patterns. Also, we are looking at educating potential clients about the regulation of arousal and providing recommendation tips to individuals on how they can keep their arousal levels regulated. So here is our solution overview. We start with obtaining an individual's data using a brain-computer interface. Then we submit the data through an API to our model, which we shall have deployed, and then that model offers a prediction, like about the arousal level of an individual with a confidence level. If the confidence is above the threshold we have set, which is about 65%, then tips are offered to an individual on how to balance their arousal, or further medical action can be taken. And the data set we used to train our model, this image here, describes it all. The dataset was publicly available on IEEE data report, and it contained 20 subjects, of which 2 of those subjects had their data was noisy, so we didn't use it for analysis that much. So basically, every subject was performing a flight simulation task where they had a joystick like this one here, and this is what they were seeing inside these VR glasses. Each of them had this headband, which we're calling a brain-computer interface, which measure the EEG signals. So we're supposed to control this joystick and make sure that they don't collide with the boundaries that you can see in this image. It was called the boundary avoidance task. So here you can see this was a control where no feedback was given. When this individual was flying the plane, you can see that they crashed at this point, and the boundaries kept reducing with time. But then when feedback was introduced, the performance became optimal. Their performance strongly improved, and they flew for a longer period of time. So the models and techniques we used, we had the logistic regression. All these are the models we used. We trained many of them on default parameters. Maybe the one I'll talk about is the ensemble. For the ensemble, what we did was we combined the XGBoost and our weakest model, which was the random forest. And when we combined them, those are the results we got. And we used all evaluation metrics, but the one we considered the most was F1 score when deploying. Our system architecture, the data we obtained was in MATLAB files, .mat files, and it is hard to work with, so we converted the data to CSV files. Then we implemented multi-strategy learning, which involved reinforcement, supervised and unsupervised learning. We used unsupervised learning to first understand the nature of our dataset because it wasn't so clear initially. Then we used supervised learning after we had managed to identify the classes to carry out exploratory data analysis. Then we preprocessed the data, removing the noise from the EEG signals, and there were some features that weren't important, physiological features, things like heart rate, breathing rate. All these were, the data was so big, all this was standing, most of it wasn't important. So we removed that data. Then we trained and evaluated the model, selected it, then we chose the model to deploy, which was XGBoost, the best model. So the implementation details we implemented using Python, and we used H5PY to convert from MATLAB files to CSV files. We used Pandas, NumPy, and the models were all got from Scikit-learn. Yes, and all this was done on Kaggle because we were collaborating online with my partner. And these were the results and the results and evaluation both on the test data. Yeah, so the impact and relevance of our project, the American Psychological Association observed among toxic countries with anxiety disorders. And as I showed you earlier in our diagram here, anxiety is one of the signs of high arousal, which leads to poor performance. So this might actually explain why our country isn't performing very well in most fronts of life. Yeah, then the SDGs, our problem solves. We have good health and well-being, quality education, because through this, as I mentioned in our objectives, people can learn how to work with this data, or they can obtain data to experiment with and discover other patterns. So that's quality education, decent work, and economic growth. This project helps enhances people's performance. Yes, and the potential users, we looked at hospitals for analyzing patients, maybe students while they are studying in class. We can implement the system such that their arousal levels are monitored to determine their attentiveness, their level of attentiveness. And then a massive user experience providers. These are, for example, people who create video games. You want to see the effect of what you have created, how many people are enlightened by what you created without actually asking them, because some of them can lie. You can connect this brain-computer interface on their heads as you show them what you've created, and you see how their brains or bodies react to it. And also advertising agencies, which can do the same thing as I just described. You create an advert and see how a group of subjects react to it. Yes, and at this point, I'll invite my colleague to talk about the intellectual property and the innovations. Yes, Bob, you're welcome.
Yes, sir. Good evening, sir. Yes, and so I'll begin just at that first minute.
Okay.
Yes, I will begin from intellectual property and innovation. So here under intellectual property and innovation, yes, so the work is cooperatable and patentable. Then also the API was to make that interact with any system to classify arousal levels, offering tips based on the arousal level, to help with either improvement or maintenance. So we are seeing that this copyright or our work is original work, like it's not like maybe AI generated or good from somewhere, but we made research and we have to come up with such a work which is original. Then the patent, that's the code. Then trade secret. We don't want anyone to know the actual implementation behind our work, data set, and methodology. Of which this is the multi-strategy. This is the multi-strategy and the reinforcement learning. So, like, we have to be with some privacy in our work, not that everyone can have a view on our back end. So, going to the next slide, that is monetization and scaling. Under scaling and monetization, you're seeing that selling advertising space on site, use clinics or hospitals, meaning our ideas, all our project will be will be shown to different clinics, hospitals, and subscriptions from potential customers. Yes, of course, you have to pay for subscribing for our services. Then Silver Brain Computer Interface, the BCI. Hope you already talked about it. That thing they put into the head machine control the brain's activities. Then teaching and training services. Of course, you'll be with different sessions or services. Then under team contributions, it's me and my colleague Joshua. You can see Sally Joshua. He made the model building and the testing and also the API programming. Then me, I was made for documentation and exploratory data analysis, making research, finding out data from different resources. So as we go to the next slide, that is lessons learned and challenges. Of course, you can't do anything successful without some challenges. So here we made some challenges. First of all, we made the challenge of lack of domain knowledge, high dimensionality of EEG data, limited resources of training models. Of course, since it's our first time and we are trying to make our research, of course, we have limited resources. So complexity and poorly available EEG data. Yes, so those are the challenges we met. Like finding out some data was really, really complex for us and getting clear images which can purely describe our topic or our problem. So going to the future work, we are looking on up to create advertising space to advertise interested clinics or hospitals, implementing payment APIs for subscription of customer. For example, someone want to access any service on our platform, it just pays directly either Airtel Money, Momo, PayPal, any. But we have to implement an AI whereby it can read details of the customer, sends money, receives message, and so on. So designing bring also have to design on the brain computing interface, the BCI, to see that it can work more based than it can work now. So providing teaching and also training services. Yes, of course, we have to train and teach our customers how to use the platform and how each own our services is used properly. So we can go to the next slide. The next slide says, thank you for watching and listening. You can have a good day for now. Thank you.